All right, so let's take a look at this normal distribution question. So it says a bakery makes two types of muffins, chocolate and banana muffins. The weights, C grams of the chocolate muffins are normally distributed with a mean of 62 grams and standard deviation 2.9. Find the probability that a randomly selected chocolate muffin weighs less than 61 grams. Okay, so we're trying to find the probability, all right, that a chocolate muffin, all right, weighs less than 61 grams, right? And they gave us all the information. We know the mean, we know the standard deviation. So since we know the mean and the standard deviation, right, we can just plug this into the calculator. This is a straight normal CDF art question. So we're going to use norm CDF. Let's type the information into our calculator. So menu, probability distributions, normal CDF. Now we're trying to find the probability that C is less than 61. Okay, so we can go ahead and leave the lower bound, right, the way it is, and the upper bound, the highest it will be, we have it at 61. Okay, and then our mean they gave us was 62, and then our standard deviation was 2.9. Okay, so 2.9 for the standard deviation. 2.9. All right, so enter. We get 0.36511. Okay, so let's type everything in. So I always like to show, okay, so we had negative 9999 dot dot dot, right? That was our lower bound. Our upper bound was 61. Our mean was 62, and standard deviation was 2.9, right? So I like to always show this to let the grader know what I put in the calculator. And our answer was approximately 0.365. Okay, so that's part A. Let's take a look at part B. All right, part B here says that in a random selection of 12 chocolate muffins, find the probability that exactly 5 weigh less than 61 grams. Okay, so when you read this, you need to recognize that this question, right, is a binomial distribution type question. Okay, so if we were to let X, right, represent a chocolate muffin, basically a chocolate muffin, all right, that weighs less than 61, all right, less than 61 grams, right? So this would be a binomial distribution because it meets our 4 requirements for a binomial distribution, right? And then our parameters are, well, 12 muffins, right? That's our number of trials. We have 12 muffins. And then the probability of success. Remember, the probability of success in this case would be, well, what's the probability the muffin, the chocolate muffin, weighs less than 61? Well, we actually calculate that in part A, right? So we know that probability is 0.365, okay? And then we're trying to calculate, so what's the probability that exactly 5 weigh? So we're trying to find the probability that X is equal to 5, so exactly 5, okay? And then we just binomial, this is gonna be a PDF, since it's an equal sign, we use binomial PDF. Let's put all the information in our calculator. So we have menu, probability distribution, binomial PDF. So number of trials, we have 12 chocolate muffins. Probability of success, 0.365. And X in this case is our 5, right? Click OK. 0.214, right? So 0.214. So we have binomial PDF. I'll show what I typed in, 12.365, comma 5, and that gave me 0.214. Okay? All right, so let's take a look at part C. The weights, capital B, grams, of banana muffins are normally distributed with a mean of 68 and a standard deviation of 3.4. each day 60% of the muffins made are chocolate. Okay? So on a particular day, a muffin is randomly selected from all those made at the bakery. Right? Find the probability that the randomly selected muffin weighs less than 61 grams. Okay? So basically we have two types of muffins. We have chocolate muffins, right? And we have banana muffins. So we're trying to find the probability that the randomly selected muffin weighs less than 61 grams. Okay? So now if 60% of the muffins are chocolate, we know that 40% are going to be banana. Right? So the number of chocolates, right, on any given day, well, chocolate is 60%, so that's 0.60 times. What's the probability that it weighs less than 61 grams? So remember, we actually calculated that previously, right? So the probability that a chocolate muffin weighs less than 61, right, was 0.365. Okay? So this right here represents the probability that on any particular day, a chocolate muffin is going to weigh less than 61 grams. Now, banana. So 40% are banana. So this would be 0.40. That's how many bananas are made in one day. What's the probability that a banana will be less than 61? Well, we actually don't know that yet. We need to calculate this, right? So basically, we need to use this information here that they gave us, right? So we're going to calculate the probability, right, that a banana is less than 61, right? So we're going to calculate this. Let's put this information into the Inspire. So menu, that's going to be a distribution, norm CDF. So probably less than 61. So the upper bound is going to be 61. The mean they gave us is 68 for banana. And then the standard deviation is 3.4. Okay, 3.4 for standard deviation. Okay, so we end up with 0.0, so this is going to give us 0.0198. 198, right? 0.0198. So 0.0198. And then, so this is the probability that a banana is less than 61. So we just multiply these, right? And then add them together. And that'll give us the probability that on any day, any muffin, all right, might weigh less than 61. So if we calculate this out, we're going to end up with, let's see, let me calculate this real quick. We get 0.227. 0.227. Okay. All right, so let's take a look at part D. So given that a randomly selected muffin weighs less than 61 grams, find the probability that it is chocolate, okay? So this question is pretty obvious that it's a conditional probability because they use the word given. So we know that this is going to be a conditional probability question. So let's set up our probability condition. So we're trying to find the probability that it is chocolate. So we're trying to find the probability that it's chocolate, right? Given, right, that a randomly selected muffin weighs less than 61. Given that the muffin weighs less than 61, right, 61 grams. So given, right, the muffin weighs less than 61, okay? So if we use our conditional probability formula, we know that the numerator is going to be the intersection of chocolate and basically the muffin weighing less than 61. Divided by the probability, right, that the muffin is less than 61 grams. Okay? So this is pretty much our conditional probability formula. Less than 61. Okay? Now, whenever you're doing a conditional probability formula in one of these multi-part questions, right, a lot of times, sometimes the numerator or the denominator it's something that you've calculated already, okay? So I notice right here the probability that a muffin is less than 61, right? We actually already calculated that. That was our answer from part C, if you recall, right? Remember in part C right here, we're trying to find the probability that the randomly selected muffin weighs less than 61. So we actually have the answer to our denominator already. It's actually 0.227, right? Now the numerator, so we're trying to find, right, the numerator here, we're trying to find the intersection of it being chocolate, right, and a muffin that weighs less than 61, okay? So remember in the question, there are 60% of the muffins a day are chocolate, okay? So to calculate this right here, right, we're gonna take, so to calculate this numerator right here, so how many chocolate muffins are there? There's 60%, so that's 0.60 times the intersection of, right, a muffin being less than 61, right? So a muffin being less than 61, if you recall, we actually already calculated this earlier as well. The probability of this was 0.365. So if you multiply this right here, so this is actually going to be our numerator, 0.60 times 0.365. So we just calculate this right here, and then this will give us our answer, which is going to turn out to be 0.965. Okay? Okay, so let's take a look at part E. So the machine that makes the chocolate muffins is adjusted so that the mean weight of the chocolate muffins remains the same. So the mean weight for chocolate muffins stays the same, but the standard deviation changes. So for chocolate muffins, right, so the mean is going to stay the same, which earlier they gave us was 62, but the standard deviation is going to change to something, okay? The machine that makes the banana muffins is not adjusted. So banana muffins stays exactly the same. So for bananas, right, the mean stays the same, which is 68, and the standard deviation is 3.4, right? The probability that the weight of a randomly selected muffin from these machines is less than 61 is now 0.157. Now before, remember we actually calculated this. This value before was 0.227, right? But now we calculated the banana one. I think this was from part C when we did this, right? When we calculated this. So when the probability of a banana muffin being less than 61 grams, that value was 0.0198, right? So now, if we take the chocolate muffins, which we know there's 60% made per day are chocolate muffins, right, from previous information, times some value we don't know, plus banana muffins was 40%, times the probability that it's less than 61 grams, that's 0.0198. That's going to give us this new value, right? Probably now is 0.157. Okay? So before, in part C, remember, we knew what this probability was, right? But since the parameters change for chocolate, we don't know in this part E, right? So we can solve for x here. So if we solve for x here, you could just calculate this in the calculator. We'll find out that x is approximately 0.248467. Okay? So once you find this right here, right, since we're trying, remember, anytime you're trying to find either the mean or the standard deviation, we know we're using the z-score formula. So z is equal to, well, what's our x value? It's 61 grams minus the mean, all right, our mean for chocolate is 62, divided by theta, which is what we're trying to find. Now the z, we know that's going to be, all right, this x value right here. So 0.248, right, 467, right? Because remember, this represents the probability, right? This represents the probability of a chocolate muffin, right? Of a chocolate muffin being less than 61 grams. So it's equal to 61 minus 62. That'll give us -1 over theta. Now remember, we need to inverse norm this value, right? So we need to inverse norm. So we need to inverse norm this value. So let me do that real quick. So menu, probability, distributions, inverse normal, and the value we're at 0.24847, right? And then remember, whenever you don't know both the mean and the standard deviation, just leave it 0, 1, right? So we get negative 0.6793218, right? So we get right here, this is going to be negative, right? 93218, right? And then if you multiply by standard deviation on both sides, you would get sigma is equal to -1. So theta is equal to -1 divided by this value right here, right? So that's going to give us positive 1.47. Okay?